Okay, we're going to do lesson 66, simplification of rational expressions, square roots of large, and I'm talking very large numbers. Okay, you might hear some background noise because all my kids are here and getting ready to do a big pool tournament. So this is going to be a little bit of a review, which will be helpful in case you forgot how to do your problems from last week or in case you missed the class. See, I told you there's already whistling in the background. So we have square root of 50, and we're going to simplify the square root of 50. The way that we did it in class was we took 50 and we did a factor tree. So we did 5 times 10, or you could have done 2 times 25, and then we can do 2 times 5. Once we get it totally prime factored, you can circle the pair. If there is a pair, that would be your perfect square. So you take out the 5 and you're left with the one that's not a pair, which would be the square root of 2. The other way you can do this same problem is you can separate 50 into the perfect square and then what's left. So 50 can separate into 25 and 2. So it's the perfect square times what's left. These two multiplied together should get what's underneath the radical. And then the square root of 25 is just 5. The square root of 2 is irrational, so it just stays square root of 2. Now you should have the perfect squares kind of memorized. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, etc., etc., etc. That's if you're going to do the second method that I talked about. You would want to have these memorized. Alright, so the problems we're going to do in this lesson, there's going to be 2 of these problems that we need to simplify, and then if they're like what's under the radical is the same, you can add the numbers in front of the radicals. So let's just start with the square root of 18. Now there's 2 ways to do it. You can either see which is the biggest perfect square that divides into 18. So let's look at that. 16 is too big. 9 would be the biggest perfect square that divides into 18. So we get the square root of 9. 9 times what gives me 18? Well, that would be 2. And then let's do 8. The biggest perfect square that divides into 8 would be 4. So we would get the square root of 4. 4 times what gives me 8? Well, it would be 2. And then we get the square root of 9 is 3 square root of 2 plus 2 square root of 2. And because these are the same, we can add the numbers in front of the radicals together, and that's the new part of this lesson. So it's going to be 5 square root of 2 is your final answer. So these aren't too bad. It's just doing 2 problems like we did in the previous lesson, and if they're the same, we can add them together. If we would have had 3 square root of 2 plus 2 square root of 3, we could not have added those together. Let's try another one. This time I'll do the factor tree instead of trying to find the biggest perfect square. So let's take 27. Let's do the factor tree. So we're going to get 3 times 9 is 27. 3 times 3. So I'm down to the end. I circle the pairs. The 3's come out. Now we already have an 8 here. This is a little bit tricky. So if I did the square root of 27, I would get the 3's come out, and we're left with the square root of 3 under the radical. You see that? This is left under the radical. Now notice that we have an 8 here as well. So what that means is we're going to keep the 8, we're going to take the 3 out, and we're going to have the square root of 3 underneath. So whatever you take out is going to be multiplied by the number that's in front of the radical. Let's do 75. Minus 3 times, I'm going to do it over here, 75 is going to be 3 times 25, and then that would be 5 times 5. Circle the pair. One of those comes out, and the one that doesn't come out is the one that didn't get circled, so it's 3. We just combine these. We get 24 square root of 3 minus 15 square root of 3, and we get 24 minus 15 would be 9 square root of 3. Okay, so hopefully you're getting a hang of how to simplify the radicals. Now I showed you two different ways. You could either do the factor tree and circle the pairs. I just lost connection with my writing tool, so hold on a second. Okay. Or you can find the biggest perfect square that goes into 27, and that would have been, we could have done 9 times 3. And this one would have been 25 times 3. Eventually I'd like you to go to this way because it's just a little bit more sophisticated. But if you can't find the biggest perfect square, then definitely do the tree. Alright, let's do the next one. Square root of 27 minus 3 square root of 18 minus 6 square root of 45. Now we already did the square root of 27, so that would be the square root of 9 times the square root of 3. This is the biggest, 9 is the biggest perfect square that divides into 27. Then we get 3, and this would be the square root of 9 times the square root of 2. 9 times 2 is 18. The first one is your perfect square. And then 45, we get 6. The biggest perfect square that divides into 45 would be 9, and what's left would be 5. Let's do 45 as a tree. 45, so we get 5 times 9, and then we get 3 times 3, so the 3 would come out, and we'd be left with the square root of 5. So this would be 3 times the square root of 5. And you can see when we do the square root of 9, we're going to get that 3. So here we go. Square root of 9 is 3 square root of 3, minus 3 square root of 9 is 3 square root of 2, minus 6 times square root of 9 is 3 square root of 5, and that's exactly what we got right here. Now we just simplify it. 3 square root of 3 minus 9 square root of 2 minus 18 square root of 5. And if you look at all those, there's no two radical terms that are like radical terms. We have a square root of 3, square root of 2, square root of 5. So we can't add any of these together. If this would have been a 3 and this a 3, we could have combined these two. So you can only combine like radical terms. Okay, hopefully that's enough practice for that. Let's go and try the next part of this lesson once my bamboo pad connects again. A little bit of problem here. So let me just do this without my bamboo pad for a minute. Now we're going to do square roots of large numbers. If you thought that last part was fun, wait till you see this part. I might not be able to write here. Bear with me a second. There we go. Oh, almost. Okay. Notice, if we have 10 squared, we get 100. If we have 100 squared, we get 10,000. And if we have 1,000 squared, we get 1,000,000. We're always going to, whenever you square a multiple of 10, you're always going to have an even number of zeros. And if you have an even number of zeros, it's always a perfect square. So if I took the square root of 1,000,000, it's half the number of zeros, so it's going to be 1,000. So just keep that in mind. Whenever there's an even number of zeros, it's a perfect square, and the perfect square is half the number of zeros. So let's look at this problem. This is 50,000. Now if you notice, there's an even number of zeros. Now you could use a factor tree for this, but I don't recommend it because it's going to take you a long, long time to get down to 2. To get down to the base of your tree. So what you want to do here is, if it's an even number of zeros, you're going to separate the number part that's not a zero with what you would have to multiply the number part to get this big number. So 5 times 10,000 will give you 50,000. Once you get this part, I told you if you have an even number of zeros, the square root of that is half the number of zeros. So it's going to be 100, because that's 2 zeros instead of 4. And then this can't be simplified, square root of 5. Now let's look at the next one. We'll count the zeros. 1, 2, 3, 4, 5. It's an odd number of zeros, so we're going to take out the first 2. So we're going to get square root of 50, and then under the radical is going to be the even number of zeros. 1, 2, 3, 4, and it's going to be 1 times 50,000. So it'll be 1 to get 50, and then we put the 4 zeros. And I wish I was teaching this in class, because this is a little bit, I'd like to see what you're thinking and see the expression on your faces. So now, if I took 50,000 times 10,000, I will get 500,000. So you have to have an even number of zeros under that second radical. So I can simplify this. 1, 2, 3, 4 zeros. So when I take the square root of it, it's going to be half as many zeros. So it's going to be 100. Now the square root of 50 we can simplify, right? Square root of 25 times the square root of 2. So that's going to be 100 times 5 square root of 2. And we're going to get 500 square root of 2. So hopefully this is making sense. We have a couple more to do. Okay, count the zeros. 1, 2, 3, 4, 5, 6, 7. Odd number of zeros. Odd number of zeros means we're going to take this out separately, and then we're going to have the number of zeros left under the second one. So there's 6 zeros, so it's going to be 1 million. Remember, when you multiply a number with zeros, you can just count your zeros, and that's how many zeros you're going to have. So we'd have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So if it's an odd number of zeros, one of the zeros has to come with the first number. So we can figure out the square root of a million. Remember, it's half the number of zeros, so it's going to be 1,000. 40 can be separated into 4, square root of 10. We can do our little tree if that makes you happier. We would have 4 times 10, 2 times 2, 2 times 5. We would circle a pair of 2's. So the 2's would come out, and we would have this left, square root of 10, times 1,000. And then you still have to simplify this. 2,000 square root of 10. Let's do one more. Count the zeros. 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros. So we can just take out the 7, we just take out the number, and then we're going to write our 8 zeros into the second one. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 zeros, not 8 digits. And then we put our commas in every 3. So the square root of 100,000 is half the number of zeros. We determined there's 8 zeros, so the square root of that would just have 4 zeros. Whoops, put that in the wrong spot. Square root of 7. And that would be your final answer. So hopefully that all made sense to you. Square roots can be really tricky. It can be something that a lot of people have trouble with. So if you're having trouble with this, you can email me and let me know, or we can go over this in class. So that's it for lesson 66.